Now let's work with 1.33. Here we have true or false, and we're going to work with some concepts. So the first problem is a probability density. So this is a probability density. It says a probability density can never be negative. Well, that is true. That's because the probability density has to always be positive, and it has to always be real. And when you take an integral, when you integrate it over all space, you have to get a value of 1, indicating that the particle has to be present somewhere in all of space. So for number 1, the answer is true. Now for part B, the state function psi can never be negative. That is false, because the state function, it can be positive / negative, it can be real or imaginary, it can be anything. We only care about the probability density. The state function doesn't really have much of a significance in terms of understanding the system. We can only understand the system described by a state function once we compute its probability density or try and compute other problems. So the state function can be anything. And there is no rule that it can never be negative. So the statement is false. Part C, the state function must be a real number. That is again false, because the state function, like I said, can be positive, negative, real, imaginary, can be anything. So the answer here is false for part C. Part D, if Z equals Z star, then Z must be a real number. This is true. That's definitely true. And now let's see why. Let's say Z is a complex number of the form A plus I times B. Now Z star is going to be A minus I times B. Now we are telling Z equals Z star, right? That implies A plus IB is equal to A minus IB. Now I can cancel out A, right? Now that would give me IB is equal to negative IB, or I can basically just add an IB to both the sides to give me 2IB equals 0. That clearly implies B is equal to 0. So the imaginary part is 0 of a complex number, which makes it, so if the imaginary part is 0, then your complex number is just A, which is a real number. So the answer for D, part D, is true. Let's look at part E. You're integrating over all space the state function, and you're saying that value has to be equal to 1. Now, this statement is clearly false. That's because when you integrate the probability density, that has to be 1, but the state function itself, the integral of the state function itself does not have to be 1. And this is not a condition. It only applies to the probability density. And so very clearly the statement is false. Now moving on to the last part of the last question. The product of a number and its complex conjugate is always a real number. Let's say you have a number and its complex conjugate. The product is always a real number. I'm going to go ahead and say that this is true. Now let's see how. Z is A plus IB, the complex conjugate is going to be A minus IB. Now let's multiply Z times Z star, which is going to be A plus IB times A minus IB, which is going to be A squared minus IAB plus IAB minus I squared B squared. So this gets cancelled and we have a squared minus I squared is actually minus 1 times b squared, which will be a squared plus b squared. And this is a real number. So the product of a number and its complex conjugate is always a real number. So the answer is true.